Chapter 5, Lesson 2 of Advanced Algebra. We're continuing to look at graphs of quadratics. Now, in the last video, we looked at quadratics where there was no linear term. So this bx term did not exist in the expression. Now we want to look at how to graph these when there is a linear term. And when there is a linear term, both this A and the B are going to affect the position of the axis of symmetry, which, remember, is also going to affect the vertex because the vertex is on the axis of symmetry. And we're going to use the values of A, B, and C to determine some characteristics of the graph when we are graphing the quadratic function. So a few things we want to do when this is the case. With the bx term, like we said, both A and B are going to affect the axis, and we're going to use those to go ahead and complete those. That's pretty much repeating what I just said. Okay, so here's a little box in your book, and these are the properties, and we'll look at these quickly, and then we'll talk about them a little bit, and then we'll do some examples. So first of all, if the equation is in standard form, and A is not 0, because remember, if A was 0, this would just be linear. The first thing we look at is whether the parabola will open up or open down. And if the A value is positive, it will open up. If the A value is negative, it will open down. So if there's a negative sign in front of the x squared term, it will open down, just like we did with the absolute value functions. And excuse me, what we call this is a reflection over the x-axis, actually, but we'll just call it a flip upside down for now. So that's the first thing we'll look at. The second thing we'll look at is try to determine where the axis of symmetry is. And remember, that's where the x-coordinate is. And we're going to be able to determine the value of the x-coordinate by doing this little equation right here, the opposite of b over 2 times a. And the b and the a are the b and the a from standard form. So the x-coordinate is equal to the opposite of b over 2a, which is also going to give me the equation of the line of symmetry, as we talked about earlier. Now, to determine the y-coordinate of the vertex, I'm going to have to substitute this value in, whichever I get, and I substitute it back into the expression for x. So I'm going to put that x value here for x squared, and I'm going to put it here, and then I'm going to simplify this expression for y, because remember, this means this is what y is equal to. So if we choose an x value, substitute it in and simplify it, we'll get the y value. So we're going to determine the specific x value of the x-coordinate by doing the opposite of b over 2a. We're going to take that number and put it into the expression to get our y-coordinate, so that's going to give us the ordered pair for the vertex. Now in function notation, f of, you remember, this means substitute the number in. So this is just a fancy way, or a function way, of saying substitute this value into the function. We're then going to get one of our points by using the y-intercept, and we know that along the y-axis, all of the y values are 0. All of the x values are 0. So the x is 0. We put 0 in for x. That's going to make anything with an x term be 0, leaving only c, the constant. So that's going to be where the line crosses, or where the parabola crosses the y-axis. And then we can use our properties of parabola, meaning the axis of symmetry. There's a corresponding point on this side that corresponds to this. So that'll give us 2 points, and then we're going to need to choose one more point, an x value of our choosing, so that we can graph one side, and then we can graph the corresponding on the other side. So we'll have a total of 5 points that will help us graph this parabola very nicely. Okay, so on the next page here, I got this narrowed down into 4 steps for graphing the parabola when you do have a linear term. Okay, so 4 steps are this. First thing you do, step 1, is you determine whether your parabola is going to open up or open down, and again, that is determined by whether there's a negative sign in front. The second thing then is to determine both the x and the y coordinate of the vertex, and in order to do that, whoops, too far, we take the opposite of b over 2a to get the x value. We then substitute that x value into the expression to get the corresponding y value. That will give me the vertex and the axis of symmetry. Once I have that, I want to then graph the y-intercept, and that again is 0, c. And then once I've done that, I'm going to choose one point an x value of my choosing, whichever I'd like to, put it into the expression, determine out its corresponding y value, graph that, and then graph the corresponding point on the other side of the axis of symmetry. Now, one note about this is when you're choosing your own x value, as we talked about before in the last lesson, the closer you can stay to the axis of symmetry, the better it is, or the more likely it is that your graph will fit on your coordinate plane. So make sure you try to stay as close to the x value or the axis of symmetry as possible when you're choosing this value. Now, this may already be taken up by the y-intercept here, so you might have to go one more over, but just try to do that the best you can. All right, I'm going to do one example. Actually, I'm going to do several examples. You watch as many as you need. As soon as you think you have it taken care of, then you can go ahead and stop the video and tackle your homework. But I'll do 5 or 6 examples. You watch as many as you need. So here's our first example, and the first thing I want to check and make sure is that it is in standard form, because if it's not, I'll want to put it in standard form to make sure that I get the right values. Then I want to determine what my A and my B and my C is. So my A value is going to be this coefficient here, 3. My B value is going to be, let's not use equal sign, let's use this. My B value is going to be negative 12, and then my C value is going to be a 10. So I want to do that first. Then I want to check and see, is this going to open up or down? Because the A value here is positive, we know that it's going to be a parabola that opens up. I then know that I can get the x value of the coordinate and the axis of symmetry by doing the opposite of the B number over 2 times A. So the opposite of B here, which is negative 12, over 2 times A. Okay, and then we simplify that. That's a 3 there. So this is 12 over 6, which is going to be 2. So the x value of my vertex is 2. Okay, and that's almost also my axis of symmetry. So I'm going to put my scale on here, and this is my x-axis, this is my y-axis, 2, 4. And then I have my axis of symmetry is at x equals 2. And I do want you to put these axes of symmetry on your paper. So my axis of symmetry is at x equals 2. And then again, I want to make sure I label that as well. Now the vertex is somewhere along this line. But where? How far up? How far down? I need to know what the y value is. So I determine the y value by taking the x value and putting it in for x, because y is equal to this value here. So I'm going to go ahead and do that. Let me scroll up a little bit and I'll come back. All right. So I take the number 2, and this is 3 times x squared minus 12 times x. Whoops. But I now know x is 2. And then that's plus 10. Okay. So we substitute those values into the expression. Let me double check, make sure I have that right. 3x squared minus 12x plus 10. Okay. And then we simplify. Now again, I have to do exponents first. So 2 squared is 4. So this is 3 times 4, which is 12, minus 24 plus 10. So this is 12 and 10 is 22 minus 24. So this is at negative 2. So 2, negative 2 is my axis of symmetry. So over 2 down to negative 2. So here's my vertex. So I want to label my vertex. Okay, so that's the second thing. The next thing is to graph the y-intercept, and that is going to be the number 0 and then the constant here, which is 10. So 0, 10 is my y-intercept. So over here it's 0, 4, 5, 6, 7, 8, 9. So right up here, 0, 10 is my y-intercept. Okay, now because I know it's a parabola, I know it's symmetrical to this line right here. So this is 2 this way. So there's going to be another point right here 2 this way. So I have those points. So then I want to go ahead and I'm just going to erase that. And I need to choose one other point, and I can go on one side or the other, it doesn't matter. And again, I want to stay as close to the axis of symmetry as I can, because that's going to make the graphing a little bit easier. So I'm going to go ahead and choose the number 1 here and substitute it into this expression. So I have 3 times 1 squared minus 12 times 1 plus 10. So this is 3 minus 12 plus 10. So this is going to be 13 minus 12, which is 1. So when I choose an x value of 1, my y value is also 1. So over 1, up 1 is a point. And again, because it's symmetrical, there's going to be a corresponding point over here. So now I have my 6 points that I can use to graph. So again, I kind of start here trying to make a nice smooth curve. Remember, this is smooth curves, it's not dot to dot. So you do the best you can, draw a line where it's a nice smooth parabola. Something like, whoops, that. All right, you get the idea. It's a little bit hard on this pad. Let me try. I think I can do better than that. Let me try. Alright, so it's going to come down, nice smooth turn, and then go up. Okay, that's not so bad. So then we go ahead and label our graph. This is 3x squared minus 12x plus 10. Okay, seems like a lot of information. It really is just a bunch of arithmetic. And again, if you remember those 4 steps, and just do those 4 steps each time, you'll be in good shape. Alright, so like I said, I'm going to do a number of other examples. As soon as you have it, you think you have it, go ahead and stop the video. Just watch as much as you need, but I think I've got about 5 more that I'm going to do for you. Okay? Alright, so here's our next example. We have negative 4x squared minus 12x plus 9. So the first thing I like to do is make sure it's in standard form, which it is. And then we're going to choose determine our values. So our a value is negative 4. Our b value is negative 12. And our c value is 9. So we know that it's going to open down because this is negative, so we want to find our axis of symmetry. So we'll do the opposite of b over 2a. So the opposite of negative 12 over 2 times negative 4. So that's positive 12 then over negative 8. Dividing both by 4, that's 3 halves, and it's negative. So the x value and my axis of symmetry is at negative 3 halves. So I'm going to put my axis of symmetry over here at negative 3 halves. Let's see, let's do this. This is my scale 2, 4. Now I'm going to wait till I put my y scale on there to see where my vertex ends up, to make sure that I have a scale that accommodates where that is. So the x value is negative 3 halves. To determine the y value, I substitute that into the expression. So this is negative 4 times negative 3 halves squared minus 12 times 3 halves, or negative 3 halves, and that's going to be plus 9. Okay, so I have that. We can go ahead and do the arithmetic on that then. So this is negative 4, and a negative times a negative is going to be positive, so this is going to be positive 9/4. And then this is a negative times a negative, so that's going to be positive. And then that's going to be 6 times 3, 18. And then this is going to be plus 9. So the 4's are going to reduce, making this minus 9 plus 18 plus 9. So 9 minus 9 is 0, so this is going to be 18. So this is going to be a positive 18. Okay, so my scale on my axis needs to accommodate that. So I'm going to go by 2, so this will be 2, 4, and this will be 6, 8, etc. Alright, so on here I go up 18, and my axis of symmetry, or I'm sorry, my vertex is going to be there. So that's negative 3 halves, positive 18 for my vertex. Now, my y-intercept, remember, is the coordinate 0 and then the c value. So here, this, kind of clean this up a little bit. So my y-intercept is at 0, and then again, that's the x-coordinate. If you substitute it in, these are going to go away. So this is going to be at 0, 9. So 0, 9, right about here is going to be my y-intercept. Okay. And because it's a parabola, I'm going to be symmetrical. So this is 1.5 this way, so 1.5 this way gives me another point. Now I want to choose another x value so I can help figure out where this goes over here. And so again, I'd like to say somewhat close to the axis. I could use a negative 1 here, but I think I'm going to choose a positive 1 because I want to see where that flows out here. So I'm going to substitute in a positive 1 then into the expression and simplify. So this is 1 squared, so this is negative 4 minus 12 plus 9. So this is negative 16 plus 9, so this is going to be a negative 7. So when I choose 1 for my x value, I go down to negative 7. So 2, 4, 6, and 1, 7. So 1, 7 ends up about right here. And then because it's symmetrical, I'm 1, 2.5 this way, so I'll go 1, 2.5 this way. And then I have my parabola. So now I just need to try and draw this without being too messy. Let's see if I can't do this. So this part is going to curve, right? And then down through here. And this is going to go down through here. And so this, my parabola, should look like that. And then we go ahead and put that equation on here. Negative 4x squared minus 12x plus 9. And this would be the graph of that. So let's see how close we got there. And I'm way off. Well, that's because the scale on that's a little bit different. Because I had used a different scale on mine. When I graphed that, I used a Y window of 20. That's why it looks a little off. But so that's what that parabola would look like. Okay, again, I'm going to continue to do 4 more examples. If you'd like to keep watching, keep watching. If not, then go ahead and wrap it up and tackle your homework when you can. Okay, our next example, again, it's in standard form already. So my A value is a negative 1, my B value is a 2, and my C value is a 1. I notice it's a negative sign, so it's going to open down. I'll keep that in mind. And then I'm going to do the opposite of B over 2A to get my X value and axis of symmetry. So the opposite of B here is a 2 over 2 times A, which is a negative 1. So it's a negative 2 over a negative 2 or a positive 1. So my vertex X coordinate is at positive 1, and so is my axis of symmetry. So I'll go ahead and put this scale on here right now. And then I'll slide my axis of symmetry on here at 1. Okay, now I need to know, I know the X or the vertex is somewhere on this line. How far up, how far down, I don't know, but I can figure that out by substituting into the expression. So this is the opposite of 1 squared plus 2 times 1 plus 1. All right, so we'll go ahead and, go ahead and calculate that. So 1 squared is 1, and then minus 1, plus 2 plus 1. So 1 minus 1 is 0, plus 2 is 2. So this gives me a y coordinate of 2. So my vertex is at 1, 2. So now that I know that that scale is going to work for me, I'll go ahead and put it on here. Now it opens down, so I'm going to label that up here on top so it's not in my way. I think I forgot to do this on the last one, but make sure you label the axis of symmetry. Then the y-intercept again is the coordinate 0 and then the constant here 1. So it crosses the y-axis, at 0, 1. And I want to label that. And it's symmetrical, so 1 this way. Now I need to choose another y value or another x value, so I get a look at this side. So I'm going to go with an x coordinate of 2 and substitute it in and see what I get when I do that. So substituting in 2 to the expression, I've got the opposite of 2 squared plus 2 times 2 plus 1. So that's 4, and the opposite of that is 4 plus 4, and then this is plus 1. So that's going to be 0, and that's going to be 1, 2, 1. So that cannot be right. Oh, yes, it can. Sorry. What did I do wrong there? I did wrong. I didn't do anything wrong. I just picked the point I already have. And now to get my third point on this side, I need to choose another x value. Now, I'd like to choose 2, but that's I already know the coordinate at 2 because I did the corresponding one, so I need to go out one further. So let's choose 3. So I'm going to substitute in 3 to the expression then. And I'm going to simplify. So 3 squared is 9, so that's opposite of that is 9. plus 6 plus 1. So that's negative 9 plus 7. So that's going to be negative 2. So when I choose 3, I get negative 2. So over 3 down 2 puts me out about right here. And again, because it's symmetrical, 1, 2, there's another point, 1, 2 over here that corresponds to that. So that gives me pretty much all I need then to draw my graph. And again, make sure it's a nice smooth curve, that it's not a dot to dot where it's real, squared up. So it should look something like that. And you see I got that pretty close. All right. Again, I'm going to do another 2 examples or so. If you want to keep watching, keep watching. If you think you got it, then go ahead and tackle your homework. All right, here's our next example. Again, it's already in standard form, so I can go ahead and just determine my A, B, and C. And then we notice that this is positive, so it's going to open up. We'll determine the x values first, and the opposite of B over 2A. So that's the opposite of 2 over 2 times A. So that's negative 2 over 2, which is negative 1. So my axis of symmetry is over here at negative 1. So I can go ahead and put my x-axis on here, or my x-scale, excuse me. And then my axis of symmetry is over here at negative 1. Now again, I know my y-coordinate of the vertex. I know it's somewhere on here. How far up, how far down, I don't know until I substitute this x value into the expression. So negative 1 squared plus 2 times negative 1 plus 1. Negative 1 times negative 1 is a positive 1. 2 times negative 1 is negative 2 plus 1. So this is 1 minus 2 plus 1, which ends up being 0. So negative 1, 0 is where my vertex is. And again, it opens up, so I'm going to put this down here where it's going to be out of the way. My second coordinate I can use is the y-intercept, and I know that's at 0 something, and it's 0 constant. So at 0, 1 is my y-intercept. And again, I want to label that. And again, because it's symmetrical, that's 1 this way. There's a corresponding point 1 this way. And then I need to choose an x value in order to, and I can choose on either side. I'm going to go ahead and choose 1 because I think it's going to be easier to work with. So I'm going to choose 1 and substitute it into the expression to find its corresponding y-coordinate. So this is 1 squared plus 2 times 1 plus 1. So it's 1 plus 2 plus 1, which is 4. So an x value of 1 produces a y value of 4. Oh, I should probably put the scale on here now that I know what it's going to be. So at 1, I'm up at 4. And again, it's corresponding. So 1, 2 this way means 1, 2 this way. There's a corresponding point. So now I have what I need to go ahead and draw my nice smooth curve, something like that. I think I forgot on the last one. Make sure you label your equation or label your graph in your picture. All right, I think that's good. Let's check that out. Let's see. I think I've got it. And you see I'm pretty close. All right, another example or 2. Again, if you'd like to keep watching, go right ahead. If not, go ahead and tackle your homework. All right, our next example here, again, it's already in standard form, so I'm going to go ahead and determine my A value, my B value, and my C value. And then I'm going to determine where the axis of symmetry is, and by doing the opposite of B over 2A. So that's the opposite of B over 2 times A. So it's going to be negative 6 over 2, which is negative 3. So I know my scale can be that. So I'm going to put my axis of symmetry at negative 3. Now again, I know the vertex is somewhere on that line. How far up, how far down, I don't know, but I can substitute the x value into the expression and find that out. So negative 3 squared plus 6 times negative 3 plus 9. So negative 3 squared is a positive 9. This is a negative 18. And this is a positive 9. So this is going to be at 0. So negative 3, 0 is my axis of symmetry or my vertex. Because it's positive, I know it's going to open up, so I'll label this down below. Now I can get my second point by using the y-intercept. I don't even know what I said there. By doing the y-intercept, which is at 0 and then the constant. So at 0, 9 is the y-intercept. So I can still use a scale of 1 here because 0, 9 would be right about here. And again, I want you to label the y-intercept. Now, because it's symmetrical, I go 1, 2, 3 this way. There's a corresponding point, 1, 2, 3 this way. So there's a point right out here. Now I need another coordinate, and again, I don't want to go out further this way. I want to stay close to this axis, so I'm going to go ahead and use negative. Well, I like dealing with ones, so I'm going to deal with -1 here. So I'm going to substitute in -1 because ones are a little bit easier mathematically to deal with than other numbers. So -1 squared plus 6 times -1 plus 9. So -1 squared is a +1. This is a -6, and then this is a 9 plus 9. So 9 and 1 is 10, minus 6 is 4. So when I choose -1, I get a +4 for y value. So -1, 4 is a point. And then again, symmetrical, 1, 2 this way, so there's another point, 1, 2 this way. So there we have all our points. So we're going to make a nice smooth curve. It looks something like that. And then we're going to go ahead and label our graph. Y equals x squared plus 6x plus 9. All right, and let's see how close we are for that one. And we're pretty close. All right, I think I have one more. Let me check. Yeah, I have one more. So if you'd like to do, again, check this out, go ahead. If not, go ahead and stop the video and check back here if you need. But I think we got this one pretty much taken care of. Actually, that's all the examples I have. So we're done with those. So hopefully those were helpful. If you need to revisit those, go ahead and rewatch the video. And that's going to be it. We got one more. We'll have one more video with this chapter dealing with what is it going to deal with? Oh, determining the minimum and the maximum value.